I want to kind of discuss a little bit more in depth of these devices between the traps, ferrites, and shunts. You talked a little bit on those. What specifically, like that big robust DEFCON, what does that is a shunt, correct?
Yeah, so essentially it's going to have a limit to the max amount of voltage it will allow it to develop across its lines, and then it will shunt away the energy to ground, all right, to the car frame, which is essentially
To the
your
chassis.
to chassis. Yeah. And so, you hook it up across the battery and over to chassis, and it has devices in it that will turn on when the voltage gets too high and drain that energy away. When it's not turning on, they really don't have any current through them at all. The only current in the device is just a little green light that's lit. So that's it.
And one way we can think about the energy that's being applied at that point when that device kicks on is, correct me if I'm wrong, is as heat. So that excess heat is being transferred into the chassis of the vehicle.
Well, it can turn into heat, certainly. Electrical energy easily turns into heat. Basically, if you flow a current through any kind of resistive material, it turns into heat and gets hot. And so certainly if we're dealing with high currents, you may see heat. But the reality of it is, in this case, you're shunting away energy before it has time to turn into heat a lot of times. So you're just taking direct electrical energy to chassis, as opposed to, let's say, shunting away a heat element, which is a little bit different, but they are related, right? And a good example of that is like the ferrite we mentioned. It does take, so you put current through along a wire and you put a ferrite around it. And as that current flows, you generate a magnetic flux in that ferrous material, which is just a magnetic field and it has these field lines. And if the current tries to change suddenly, like a big pulse gets injected, right? It tries to change suddenly. The magnetic flux in the ferrite doesn't want to change. It acts like it's kind of like a spring damper. And it is, in fact, changing the magnetic field variation into heat. A very, very small amount of heat, you wouldn't be able to measure it yourself, but indeed that is what it's converting it to, is it's changing this magnetic flux variation into heat, so that on the other side of the ferrite you don't see the current pulse. You only see it on the input side, not the output side. And so there's this interrelation of changing energy states, yeah.
So a shunt would be more or less like a pressure relief valve. A
Yeah.
ferrite would be more like a filter that
Mhm.
is grabbing all that excess and dialing it down to what it's supposed to be by suppressing a bit of that energy,
Mhm.
like you said, as heat. And then the traps. How do the traps
So those
particularly?
are very similar to the DEF CON, except they use a different device in them. The DEF CON uses metal oxide varistors, which are very standard, heavy-duty, high current shunting devices. The traps, all the trap products use a transient voltage suppressing diode, a TVS diode it's called. And the advantage of those is they're super fast. They turn on in a few picoseconds. And so they're plenty fast enough to turn on for E1. They don't have a lot of people, the big question I had when I first came out with the track is, how could something so small protect against an EMP? It doesn't make any sense. All right, what are you talking about? But I actually did a YouTube video where I calculate out how much energy it is. And the reason the EMP is so harmful is not that it's a ton of energy, it's that it's a small energy in a very, very tiny amount of time. All right, and so it looks like a ton of energy because it occurs in such a brief amount of time. And as long as you have enough capacity in the device that turns on to handle that very brief pulse, that E1 pulse, which is about zero point 0.1 joules per square meter. It doesn't sound like a lot of energy, but again, it happens in nanoseconds. As long as you can turn it on fast enough, you can shunt that energy away. And indeed it does. I show the calculations, show that it works, and I do a little demo and stuff of how it works. But so the idea is to have devices that are fast enough to turn on for E1, and that these traps, that's the idea of the traps, and devices that are robust enough to handle all of the energy that might be introduced over E1 and E2, and that's like the DEF CON, for example. But there are different parts in them, there's different components, but they have very similar functions. They're both trying to shunt energy away.